Yep, there we go. All right, welcome everyone to our topic on insulated concrete form construction and foundations. I'd like to introduce you to Tyler, who I've known Tyler and his partner for a few years. They've been big supporters of First Nations. They're usually in Saskatchewan at many of the housing conferences, talking about their products and foundations and stuff. And so Tyler, he's the co-owner and manager of Prairie ICF. He's the authorized dealer of Nutra Distributors. They're based in Martinville, Saskatchewan. He completed his Bachelor's of Commerce at the University of Saskatchewan in 2007, and he joined Prairie ICF as a sales rep, and eventually he evolved into his current position. So Prairie ICF, they specialize solely in insulated concrete forms that are responsible for building envelope products. It's one of the prominent ICF distributors in Western Canada, and they're the main supplier of Nutra, and they're the largest ICF manufacturers in the world. I didn't know that. So he's active in industry groups. He's included Saskatchewan Construction Association, Saskatoon Regional Housing Building Association, and Concrete Saskatchewan. He's on their board of directors, and he enjoys hockey, golf, camping, and he's a family man. So that's good. So I'll turn it over to Tyler at this stage.
Great. Thanks, John, and thank you everyone for joining, for taking the time to sit through this. We'll get started here. At any point, if anybody has some questions, feel free to just jump in on the chat or raise your hand, and I think either John or Claude will sort of mediate the questions as we go. There should also be some time at the end for any additional questions if there's some remaining. So roughly what I'm going to cover today, a quick introduction to myself, my company, and Nudura, the manufacturer we partner with. We'll kind of go over what is ICF, the history of the product, some of the construction steps, and some considerations that have to be taken when you're building with ICF. I want to touch on code issues, different ways to find your structural reinforcement, energy code, which is now, I believe, adopted in every province for a number of years. Some fire and sound rating, vapor permeance, downproofing, and then some specialty things. So how plumbing and electrical are done, which differs slightly from wood frame construction that everybody here is familiar with, I'm sure. Little bit of problems that can arise because there are certain challenges you have to be aware of, certification, and what's in store for the future of the technology. So myself, like John kind of said, I work construction through high school and university, so that sort of spawned a real interest in the industry. Received my Bachelor of Commerce from the U of S, and as I was wrapping it up, I actually began my career with this company. 2007, so I've got about 15 and a half years in the ICF industry. So we kind of had a front row seat to the evolution of the technology and how it was adopted and how the uses of this have changed over that time. And we've provided material for residential and commercial projects throughout a lot of Western Canada, below grade, above grade buildings, residential, commercial. So we've got a pretty broad scope of experience with the products. Our company actually began with my business partner, Jesse. He wanted to build his own house. So back in the early 2000s, looking for ways to build something that is a little more energy efficient, did a lot of research, and eventually stumbled across insulated concrete forms, and Nudura was the recommended brand. So built his own house, thought it was something that had promise in the area. Got the distribution rights from Nudura, and kind of took off from there. Originally, we were located in North Battleford, Saskatchewan, and we currently operate out of Martinsville, which is just north of Saskatoon, if you're not familiar. And again, we stay active on numerous industry boards. So Nudura as a company, they were incorporated in 2001. head office is in Barrie, Ontario. They have various production facilities throughout North America. So there's one in southern Alberta that services Western Canada and the Northwest United States. Our main manufacturing facility is in Granby, Quebec. There's another one in Georgia, and a couple more coming online shortly. And out of the North American facilities, they actually service worldwide. So they have good representation throughout Europe, Australia, the Caribbean, through the Middle East. They really are a global company, and finding success in a lot of different areas. And Nudura is now part of the Tremco Construction Products Group. Power of one. So that's the warranty. And this is something I don't want to, this I'm hoping isn't going to be a huge sales pitch, but this is something that really excited me. So Tremco, which in turn is owned by RPM International. RPM took all of their construction products and put them under the Tremco banner. And the unique thing that they're able to do with that is give this power of one warranty. And what that means is you can have one manufacturer that basically warranties your entire building envelope. So that would include Nudura for the walls, for instance. There's a Tremco flat roofing line, Drive-It acrylic stuccos, for instance. There's window sealing products. There's expansion joint products. So they have this complete product line that now allows you to actually get a complete building envelope warranty from one supplier. And that's something that really excited me when I first heard of it. And also Nudura is one of the founding members of the ICF-MA, which is the Insulated Concrete Form Manufacturers Association. Okay, so let's get into it. What is ICF? An ICF, or an insulated concrete form, is a preformed unit that is set in place, filled with concrete to provide structural stability, insulation, fire protection, sound reduction, and a barrier from water and air. So basically, and we'll go over this in a little more detail, it's a big Lego block that gives you all of your building envelope needs with one product, essentially. Nudura forms are comprised of 2 layers of expanded polystyrene, or EPS. EPS is a unique product. I shouldn't say unique, but it's interesting in the foam plastics world because it doesn't off gas. It doesn't have it's a completely inert product. So there's no issues with using it in an interior application. Most ICF companies use EPS foam as their main agent for their insulation panels. Nudura's in particular are 2 5/8 inches of foam on each side of the concrete, and that can change from manufacturer to manufacturer. Typically from 2-inch to 2 3/4 inch is sort of industry standard. And then there's a variety of core sizes, and that refers to the thickness of the concrete. So with Nudura's product in particular, it ranges from 4-inch up to 12-inch thick concrete. And with unassembled products and connectors, you can go up beyond the 12-inch size. And again, depending on the manufacturer, that's not always the case. Some are limited, and some have the same options. ICF products give the construction professional and homeowner the ability to create a structure with increased strength and longevity, while reducing construction times in a cost-effective manner that result in long-term savings in energy costs. And that's the number one reason that people are going to ICF, is for the energy cost. But there are a lot of secondary benefits that we'll touch on kind of as we go through this that become even more important, I think, in some applications. And they're not just for foundations. So we can do not only below grade, but we can do above grade walls, residential, commercial, and institutional buildings. And that's something that's becoming more and more commonplace. It always used to be that, ICF was that way to build basements, and now it's becoming more prevalent, and in certain areas to see not only foundations but above grade walls be built with concrete as well. So the history of ICF. And this is something that might surprise you. Most people, again, think of ICFs as that, like a new way to build a basement, but the first systems were actually introduced in Europe in the 1950s. It was actually as a result of the rebuild after World War II. Lumber was becoming in short supply, and they needed to find alternatives to assist in the rebuild. So kind of an archaic version of an ICF was introduced to sort of help with that rebuild. North America, the first patent on ICF in North America was in the Ottawa region in, I believe, 1968. I think the earliest ICF foundation I'm aware of in our area, at least, was 1976. So again, it seems like a rather new technology, but believe it or not, it's been around for longer than most people realize. And it was officially adopted into the National Building Code of Canada in 2005, which means in Saskatchewan is October of 2009 when we became an actual code-approved product. And there's currently around 24 manufacturers in North America, and there's some smaller regional ones that we really don't see. Probably about 8 to 10 manufacturers are going to occupy, 95+% of the market in all likelihood. So what does an ICF wall give us? Like I said, you accomplish multiple steps with one product. So 6 steps in one. The forming. So obviously instead of a plywood form and your ties, you just have the ICF block replacing that. Your structure, which is provided with typically steel reinforced concrete. Insulation, again, the 2 layers of EPS foam are going to give you a good level of insulation. Vapor barrier, again, the density and the thickness of the foam does qualify as a vapor barrier. Your air barrier, so again, typically no outside wrap is needed for above grade. And the furring strip. So there's an embedded plastic tie, and you can see in the cutaway of that form, again, depending on the product, 6 inches to 8 inches on center. You'll typically have an 1.5 inch wide plastic furring strip that's about a 1/2 inch or so below the surface. And that's going to be what you use to do your exterior finish will be mechanically fastened to that, and interior, whether it be drywall or plywood. So steps to building an ICF wall. Prepare the footings for a block. It doesn't have to be footings. We'll go through a few different options. Footings are the most common. Again, just your typical strip footing. You'll either use dowels or a keyway to provide the lateral support for the base of the ICF wall. But you can also build, on piles. You can build on a thickened edge slab. You could scribe it to bedrock. But some type of foundations. Footings we do find are the most common. Stack forms and create openings. So again, there's typically preformed 90 and 45-degree corners as well as straight blocks. Nothing needs to be custom manufactured for this type of construction. You can sort of cut on site to suit whatever you need. Makes it easy to do changes on the fly if you need to add a doorway or change the size of a window or something like that. So it's just a standard panel that you cut on site to suit the plans. Again, they go together very much like Lego block. Place rebar in the walls. There's notches that you can see there that the horizontal rebar will tie into. The size and the spacing of the rebar is going to be dictated basically by the site conditions. So wall heights, backfill height, wind load, block size, things like that. The alignment system that we have here, it's going to depend again on the height of the wall. If you're doing a crawl space, you might use a shorter turnbuckle or just solid dimensional lumber to brace that wall. Here you see a specialty steel ICF bracing system, typically spaced 5 to 6 feet on center. And you can see it incorporates a metal strong back that gets screwed to the wall to keep it plumb, a scaffold bracket, and that angle piece is actually an adjustable turnbuckle. So when you're setting up these forms, the corners will be plumbed. The walls will actually lean in toward the bracing prior to concrete placement. And then once the concrete is in, you turn those turnbuckles to straighten it to a string line after the concrete's in. So it really makes it easy to control that wall, get a nice straight pour, and ensure that that the next day your wall is looking good and it's sitting where it's supposed to be. And then you pour the concrete into the wall. Make sure you consolidate it properly. We typically do that with an internal vibrator, but there are a few other options. And then you install your electrical, plumbing, and roof. So at the top of that wall, you're going to normally bolt some dimensional lumber as a mud sill. Put the roof system on top of that and secure it down, whether it be with spikes or hurricane ties. And the plumbing and the electrical just get channeled straight into the EPS foam, which we'll touch on in a little more detail here shortly. So I'll just show you some of the different projects that you can do with Nudura's products, or with any ICF, I suppose. A couple things I want to point out about these pictures you see. On the top right, so that's just a crawl space. You can see they've got a treated sill plate bolted down to the top of it. Just at the bottom of the picture, you can see a membrane. That's the peel and stick damp proofing that we offer for for anything that's below grade level. And on the inside, that pink and blue, that's a just a rigid insulation that this homeowner opted to put into the crawl space. Again, it completes a really nice completes the building envelope really nicely when that rigid foam underneath the basement slab ties in directly to the EPS foam in the ICF. So gives you a nice warm basement. And the other thing I should note is that EPS foam, I've been told, is also an effective barrier against radon. So assuming you have like a shiplap design in that underslab insulation, you shouldn't need any additional tape or poly or anything like that. Just your regular radon caulking around the perimeter and around any penetrations through the slab. The top, or the two on the left rather, that's the same foundation. You can see it's a crawl space, and there's actually an attached garage there as well. So a couple things interesting about that one. The crawl space, now this particular project is has a homeowner with limited mobility. So they didn't want a bunch of steps. They just wanted basically one step into the house. So that crawl space is actually built up to the top of the floor system. So that picture on the top right, you'll just frame your floor system on top of that mud sill and continue up with a framed wall for the main floor. The pictures on the left, they're actually using a hanger system. So their hangers are cast into the concrete, and then the floor is hung inside the ICF. And the reason you want to do it that way is now when you're backfilling up to the top, basically 6 inches down from the top of the main floor, your backfill isn't up against a wooden rim board. It's actually up against the ICF. So it's something that's going to take the moisture really well. You don't have to worry about rot or any degradation. And you've also got a nice insulated rim board as well. The other thing with the attached garage, now because you're going to fill the inside of that and the outside of that wall to the same level, it actually doesn't need downproofing. And again, we'll go over downproofing.
阿明，我是 Douglas。
Sorry, hello? Did you have a question?
我看看因为明天后天我这2天都不在，约下周一或者周3吧。
Okay, I'm not sure what's happening there. That was Douglas.
Okay.
On the other line there. Okay. Sorry about that.
No problem. Okay, so then the last picture there on the bottom right, this was a project on a First Nations community in Saskatchewan, and they went for a modular home. So they used Nudura. You can sort of see it there at the base of the cranes as crawl space. They craned the two halves of the modular unit on there. And again, it's simplicity of construction. It gives you that insulation level, and it's something that's going to be durable as far as resisting any backfill, moisture, alkalinity in the soil, things like that, because now it's a protected concrete, and both the concrete and the EPS foam are protected from any rot or degradation from moisture or alkalinity in the soil, which is important. Grade beams, and this is a question that we get quite often. I think out in Eastern Canada, I don't know if pile and grade beam foundations are as common as they are in the West. So quick answer, yes, you can absolutely do grade beams with insulated concrete forms. A lot of the same considerations have to be made when compared to a cast in place grade beam. So you still need to have, the same concrete thickness and depth that you would normally have, or an engineer wants. Your rebar would still be placed in the same way. And then you can see on that picture, the lower picture, if you look at the base of that wall, you can actually see a fingered EPS frost cushion. And that's important, again, just so any frost heave, you still have that frost cushion in place that's going to compress and absorb that movement rather than it pushing up and damaging the concrete in the ICF. And you'll also notice they're building in winter, and on the bottom left of that picture, there's an orange tarp there. And that is important just to make sure you're keeping the snow and ice out of the blocks. Winter construction with insulated concrete forms ICF is very conducive to winter construction because the forms themselves are already insulated. And as concrete cures, it releases heat. So it is an exothermic reaction. It generates its own heat as it cures. So simply covering up the exposed concrete and allowing the forms themselves to trap that heat within the wall. We've placed concrete into our forms as low as -25, -30 degrees Celsius. Typically, I find that the pump trucks usually tell you, no, we don't want to pour it too hard on the equipment before the forms aren't able to accommodate the weather. Full height basements. So again, same as a grade beam, you just go up a little higher. There's allowance for window designs, concrete lintels over. The one thing I do want to point out on this slide, the top right, so it's an ICF basement, and you can see the attached garage is just cast in place concrete. Typically, when we do those connections, you want to remove the foam, which is done in this case. So remove the foam so that the concrete in the grade beam is in direct contact with the concrete in the basement, and that's just to avoid any shear force where that 2.5 inches or so of EPS foam is. The other thing that I would do or should be done prior to backfill on this garage on that top right picture is, now you don't have to damp-proof the grade beam on the garage, but I would continue that membrane for about the first 2 to 3 feet onto the grade beam, just so that you don't have any water migrating through the porous concrete laterally. So it'll go in through the grade beam and sort of make its way sideways and appear into the basement. So just giving a few feet of protection against that exposed concrete would be a smart detail. Full ICF home. So again, we can build not just foundations, we can go right up to the rafters. You'll see in the top left, on the far side, they even did a vault on that home. So you can do that with ICF, and we've gone right up to a 10-12 pitch if you want to enclose a vaulted ceiling with ICF and maintain a consistent building envelope. The other thing you'll notice is you can see the elevation on the outside of that house where the floor system attaches to the exterior wall, and you'll notice there's no break in it, right? So the ICF wall continues straight up, and where that rim board normally would be in a framed house, and you have the connection from, say, the top of the ICF wall or a concrete wall to your rim board to your 2x6 wall above, for instance, we don't have those connections. So it's a consistent wall all the way up, and it offers a lot of protection from, as far as insulation goes, as well as from moisture, from wind, rain, snow, things like that. Top right, that's a slab on grade home, and that's another pretty common question that we get, is if the product works for slab on grade homes, and absolutely it does. And especially if you're looking at First Nations communities, we've done a number of slab on grade homes, largely because space typically isn't an issue, so going up or going down isn't necessary. And again, if you're looking at an aging population and you want to have minimal entrance or minimal steps, you can build out. You'll typically, in this case, they would have done a frost wall about 4 feet below grade. There's different ways to make sure you're having a solid connection to the interior slab. They'll go up, pour the main floor walls, put the roof on, and again, it's fully insulated and ready for your interior and exterior finish. Couple houses on the bottom, again, those are both full ICF homes. Just shows you the versatility. So you can do radius forms, you can do a variety of finishes, whether it be here we have direct applied stucco and some stone. We could put siding, we can do hardy board directly on it. So you're really not limited as far as your aesthetic and your interior exterior finish when you're switching to an ICF product. Multifamily homes. So again, something that's getting more and more popular within certain communities. You'll see the top left there is a 5-unit, basically row housing. And you'll notice on the top right, that's the same project at the foundation stage. And there's interior walls there as well. And those actually serve two purposes. They acted as shear walls because it was a very heavy, expansive clay where this project was built. It also provides a really good level of both fire and sound rating for the neighboring residences. I'll talk a little bit more about the sound and fire rating, but that's really important to consider is doing interior walls if you're doing a multifamily. Just because it gives you that good separation and it doesn't sound like you're living in the next room to someone. Bottom right, that's not multifamily. That's actually a hotel that was done. But as far as I'm aware, still the tallest ICF building in Saskatchewan. That's an addition 1 floor below and 3 floors above all ICF, including the elevator shaft. Bottom left, not in Saskatchewan. That's London, Ontario. That was a 19-story project done all with Nudura. The interesting thing about that is it's actually all load bearing. So they started with the first handful of floors were a 12-inch concrete thickness, then they reduced to 10, then to 8, and the top handful of floors went down to a 6-inch. So as the load decreased, they were able to reduce the weight imposed on the foundation. And some light commercial. So that top left, that's a family services building on a First Nations community here in Saskatchewan. They used our XR35, so they increased the R value to about a 35. So That particular form has the EPS foam going from a 2 5/8 actually up to 4 inches of foam on each side. So again, it'll really cut down on their heating and cooling bills. If I'm not mistaken, this building may have gone with electric heat. So if you're able to reduce the heating load and you're looking at a really high cost per BTU on your heating system, then your payback time is becomes really attractive. Top right, that's an old RM shop that we supplied a number of years ago. Again, full ICF, tin exterior. They were really concerned about combustibility. So because they had machinery in there, lots of oil, fuels, things like that, that was a largest part of the decision, was the fact that fire wouldn't become an issue with that type of building. And bottom left, just a multi-unit commercial retail unit that was just wrapped up earlier this year. And you can see the same building on the right with, again, a variety of finishes. So they have some steel siding, masonry, a few different types of stucco on there. So again, just showing the product versatility. So some different construction details, and this would be, a lot of this is deals with above grade ICF construction. So floor hangers, again, you're doing basically balloon framing. Those exterior walls are going to go all the way up, and the floors, the intermediate floors, are going to hang off of the inside. When you're building this, you're going to normally do one floor at a time. So we would pour, if we were doing a two level house, for instance, we'd pour the basement, have the floor hangers get wet cast into the concrete. The floor is then framed, sheeted, and when you do your main floor walls in ICF, you just brace it down to that first floor system. And again, one floor at a time. So that 19-story building would have just been one floor at a time, and you're constantly bracing down to the successive floor systems. Vapor barriers, not required. We're going to touch on that in a little bit. But again, you have to double check if there's a different product being used. You might have to get the testing reports, but most products have the proper density of EPS foam as well as the proper thickness to qualify as a vapor barrier without an additional poly being installed. Got to be careful, avoid some adhesives. Again, anything solvent based will actually react with the foam and basically dissolve it. So something like a PL 400 will not work on an EPS foam, but if you're just careful and you look at the adhesives that you are using, it will typically list it as safe on foam plastics or safe on polystyrene. So something like a PL premium is normally what we go with. So thermal bridging, if you're getting into the real high energy efficient homes, then really the devil is in the details. So you can get to 90% efficient quite easily just by having a well insulated wall. But if you're going to get to net zero or passive house standard, then we have to consider the thermal bridging. So at the windows and doors, make sure you have a thermal break. At your sill plate, make sure you just don't have a path for the cold to get through. So hanging on the walls. Now, because you have a plastic tie every 8 inches on center, again, you got to check your product specs. They will have pullout ratings typically for the plastic ties, so you'll know how much weight a given size of screw can hold. Cupboards are an interesting one. So when you get the uppers in place, the most common way to do it is just before you drywall, mark out where the uppers are going to be in the kitchen and screw a 1/2 inch plywood into the ties, slightly smaller than those uppers. Then when you put your 1/2 inch gypsum board on, it will all be flush. And when you put your uppers on, they can just screw anywhere directly into that 1/2 inch plywood. So a little bit of pre-planning goes into it, but it's pretty simple to accommodate. And different types of finishes. So again, making sure you have appropriate thermal barriers on the interior for the exposed EPS foam. Your exterior finish, stucco, siding, stone, brick, kind of whatever you want, but just make sure that there's pre-planning in place. So something like a manufactured stone product can hang directly off of your metal lath, whereas if it's a real stone or a real brick, then typically some additional support will have to be provided, which oftentimes is easier to do in the pre-planning stage and the building stage rather than trying to retrofit something. So again, why are people going to the trouble of switching to ICF? So using ICF in the construction of above and below grade walls meets and often exceeds statutory building codes. So they're found to be up to about 9 times stronger. There's a hurricane rating of about 250 miles per hour with 115 mile per hour debris impact. So it exceeds wood framed or concrete blocks. There's a really cool video on YouTube. I was going to upload it to my presentation here, but it doesn't show my block, so I didn't want to do a disservice. basically what they do for these impact debris tests is they load a cannon with a 2x4 and shoot it at a wall. And so they did this one particular video. They shot it at a 2x4 wall, and it went straight through and kept on going. Didn't even slow it down. A steel wall, same thing, right through the metal exterior, and the 2x4 continued on. A brick wall, it even punctured through a brick wall. Now it absolutely shattered the 2x4, but it did puncture and did cause pretty significant damage to the masonry wall. Then they shot it at an ICF wall, and it basically took out the exterior finish. It compressed the EPS foam, but as soon as that 2x4 hit the concrete core, it absolutely exploded. Then they removed the EPS foam from the outside and the interior of that impact point just to check the concrete for any damage and spalling. And they found that it held up really, really well. So that's how we get such a great hurricane or hurricane rating. Hurricane's not a big concern for most of Canada, although out east you did have to deal with that, unfortunately, earlier this year. Tornadoes more of a concern out west, but again gives you that assurance that you've got an extra level of safety. Fire resistance rating of up to 4 hours versus only 20 minutes with a stick framed house. Again, just almost solely attributed to the concrete core. 3 times greater sound resistance, so a sound transmission class or STC rating of 50 using 6-inch forms. That's really important. Again, if we go back to the multifamily housing, so if you're doing something like a duplex or a multifamily building, between suites you need at least an STC of 50. So a 6-inch ICF wall just with a regular 1/2-inch drywall attached will provide that. And 2 times more energy efficient. So the R23.59 rating of a Nudura ICF wall, it's equivalent to about an R40 to R50 stick frame, and largely due to the reduced thermal bridging. Again, the insulation in an ICF wall is continuous. You don't have those weak points at every stud like you do with a framed wall. So if we go to the R value, so section 936, which is the energy efficiency portion of NBC, again, Nudura's whole wall R value is 23.59. It will change again if you're looking at a different ICF block, but there's going to be somewhere in that ballpark. You can go to a thicker EPS form if you're going for net zero, or in the commercial world, if you're going for NECB compliance. I know in our area, they're typically shooting for about an R27 under NECB. So we do have things like the XR35. A lot of manufacturers have inserts or additional foam you can add. So there are options to increase the R value beyond that, R23, 24 rating. So again, we exceed 936 requirements for above and below grade walls for all climate zones. I say all climate zones. Now, being in Saskatchewan, we go from zone 5A up to zone 8. I don't know if anybody is outside that scope, but I know from 5A to 8, we exceed the requirements, the prescriptive requirements for above grade, below grade, with or without HRV. Tested equivalents R40 to R50. This is a bit of a sticking point. So we've had a lot of our competitors that the sales side of it, they'll say, well, we got an R40 wall. That's not true. We don't have an R40 wall. That's not how R value works. Where that number comes from, there's a test done that's got to be pushing 20 years ago. And basically an independent engineer said to build a stick frame wall with the same thermal performance as an ICF wall, that stick frame wall would have to be built to an R40 to R50 standard. So that doesn't mean that ICF is suddenly an R40. What it more so means is that a wood wall is not actually R20. And I think that's getting to be pretty common knowledge. A high mass wall assembly. So again, having that concrete in there really helps against temperature fluctuations. So as it warms up during the day, you're going to sort of passively heat up that large mass inside the wall. As it cools down at night, it's going to passively let off some of that heat to the inside. So again, going back to that thermal bridging, if you take a 2x6 wall at 16-inch on center, you're putting an R20 batt into there, you squeeze it into the 5.5-inch stud spacing, it reduces the rating to R19, and your wood is about 23% of that outside of that exterior wall is wood. So you end up with a whole wall R value in the R13 to 14 range, which again doesn't meet the 936 requirements, at least in zone 7A where I'm sitting right now. I believe they're looking for about an R17.5, which again, the ICF value of that 23.59 for Nudura at least it exceeds that, there's no loss because there's no thermal bridging. So your true R value and your whole wall R value is the same thing. And the air tightness. Now, when you have a monolithic concrete wall, that's inherently airtight. Making sure that your windows and doors are sealed up properly, obviously, is important. But you're not going to have that passive air movement that you can get with a lot of other buildings. So again, here's just a quick shot of a thermal imaging camera. So on the left, an ICF home. On the right, the stick frame. So that really goes to show you can visualize the thermal bridging. The rim board is a really bad spot. You can see all your studs show up quite clearly, just showing the amount of heat loss. You can even see this. I know oftentimes this time of year, if you get a little bit of dew on the wall, you can see every one of the studs because there's enough heat loss to actually evaporate it, whereas in between actually is a bit cooler. So air tightness is done with a blower door test. A typical stick frame house is around 3.5 air changes per hour. And that's important when you're looking at heating the home, because basically every hour you heat the home, you lose that air, you heat it, you lose it 3.5 times every hour. ICF, I've heard of testing as low as 0.24 air changes per hour. I've heard of testing even lower than that. I had one guy tell me they weren't able to get a reading on an ICF house, which those machines are pretty, I think his machine needs to be recalibrated because those are pretty sensitive instruments. Healthier indoor air quality, again, because it's airtight, you're able to control the air coming in and out. There's no off-gassing. With EPS foam, again, it's completely inert, and no mold or mildew growth. So there's nothing in an ICF wall that will support it. So, to get mold to grow, you need to have three things. You need to have moisture, you need to have a source of nutrition, and you need to have heat. And if you take out any one of those, then you can't support mold growth. So the EPS foam, the concrete, none of that is going to be, it provides zero nutritional value for mold. So you've eliminated or greatly reduced any chance of mold growth. Now, of course, there is still the paper on the drywall and other building products, but the ICF itself will not support mold growth. And because it is so airtight, an HRV or an ERV is required just to make sure you do get some level of mechanical ventilation through that home. Structural requirements. So we can look at NBC. We're on the 2015 edition currently. You can look at a products engineering, the ICF-MA report, CCMC report. Now, most of them have expired, and I'll explain why. Or you can just go to site-specific engineering. So all the first four, they're all just sort of a blanket design. If you fall outside of that scope, then you go to site-specific engineering and some local bylaws. So there are certain municipalities that might say, okay, we want all of our foundations to be 8-inch concrete minimum. We won't allow 6-inch, and that's very much their right. So if we go to NBC, now they do distinguish a concrete wall from an ICF wall. So structurally, they do list them as two separate things. They only allow for a flat ICF. Now, if you look at the three pictures on the bottom, those are the three kind of basic types of ICF. The left is a flat, so it's a continuous thickness. On the far right is a screen. So in between, that's what your concrete would look like. In between is solid insulation. The waffle grid sort of combines the two. The problem with the second and the third, or I guess the benefit of the second and the third option is you reduce the amount of concrete that you need. The downside is that it's a lot harder to consolidate the concrete. So for simplicity, NBC only allows the flat style. One thing that they do, they say things like it has to be laterally supported bottom and top with an ICF. So you can't do a 4-foot, bi-level home. You can do it 4-foot cast in place concrete. You can't do it 4 feet with ICF. Now, certain manufacturers do have engineering to address that independent of NBC. But it's sort of one of those shortcomings of NBC. And I think some of these kinks will be worked out because structurally it is the same thing. And many building inspectors do say, oh no, we'll allow the equivalence as long as you have the same structural design, whether it's 8 inches of concrete formed with plywood or 8 inches formed with ICF. We know structurally that it's giving you the same thing. So this is basically a table out of NBC. Very simple to read, gives you your wall height, your backfill height, and tells you what rebar you need vertically. If we go to Nudura's engineering, this isn't even the full table. It goes a lot more into detail. So this shows 2 of the soil types offered. There's a third one on the next page in the book, not on the slide. But gives you a number of different wall heights, a number of different backfill heights, again, for different core sizes. I do prefer this just because it's a lot more detailed than NBC. And I did a comparison, and in no case does NBC require more rebar than Nudura. Oftentimes Nudura requires more, or it's not even allowed at a given core size, and it makes you go up. So a larger safety factor and more detailed. And again, each product should have their own engineering that's going to be something similar to this. ICFMA, so the Insulated Concrete Form Manufacturers Association, they put together tables similar to Nudura. So again, with multiple soil types, multiple wind loads for above grade walls, and it's approved for use for all ICFA manufacturer members. There is also an allowance for ideal rebar spacing. So there's different block sizes. They'll be 12 inches or 16 inches high or 18 inches high. So they do offer rebar spacings to best suit the product that you're using, as long as it's an ICFMA member product. And those are, again, approved for uses throughout Canada. CCMC report, most products, the vast majority of ICFs allowed their CCMC report to expire once NBC adopted the use of ICF. It was way over designed. In fact, to the point that the amount of steel that the CCMC report called for, you could pay an engineer to tell you needed to use less and you'd still be money ahead. So again, it was a pretty straightforward table, but it was too over designed to be practically helpful. Rebar layout's very important. If you look at this slide, the bottom block has you see that round, that horizontal rebar sitting in the left of the center notch, and then in the upper block, the same corresponding horizontal rebar is in the right side of that vertical rebar. And you would stagger like this. So the placement of the horizontal rebar isn't really important, other than it's going to hold your vertical rebar where it needs. So this would be typical layout for an above grade wall to the center line of the concrete. Below grade, it would typically be to the inside face for a wall that's laterally supported bottom and top, but it can change based on the application. But as you go up, you'll put your horizontal rebar in opposing notches, whether it be the center, the inside, or the exterior face. And then once the wall is up, your vertical rebar get threaded through there to be placed in the spot where they're most effective, to the tension side normally. Okay, so we'll touch on fire and sound rating. I hope I'm not going to go too long here. I'll try and wrap it up. Typical fire rating of the forms is 3 to 4 hours, again, dependent on the manufacturer. This is a test that each manufacturer has to do independently. So it's tested with a 1/2-inch drywall to structural failure. And exposed foam plastics must be covered by an effective thermal barrier and habitable living space. Again, that's just an NBC requirement. These tests are really, really neat. They actually build a full wall inside a lab. So they have the ICF, the concrete, the rebar. They would add the gypsum board. They'd mud and tape it. I don't know. They might even go to the point of painting it. Then they put that whole section of wall in a kiln and burn it at, I believe it's something like 11 or 1200 degrees. So if you're going for a 4-hour rating, for instance, they would burn it for 4 hours. Now, after about 15 or 20 minutes, the drywall and the foam is all gone, and you're just burning concrete at that point. But after the 4-hour mark, they pull it out, and then they immediately start dousing it with a fire hose with cold water, just to see if that temperature change affects it. After it's cooled off, they look at the concrete, and as long as there's no indication of spalling or structural damage, then you've passed that test for a 4-hour rating. So it's a pretty robust test, and ICF performs very, very well under those conditions. So if you look in 910, 1710 in NBC, it'll tell you the approved thermal barriers that can be used on the inside of an ICF wall. So you can do plaster, gypsum board, plywood, hardboard, insulating fiberboard, OSB, or any material complying with CAN ULCS 124, which is the test for thermal barrier. Most common is gypsum board. You don't need to mud and tape it. It just needs to be physically screwed to the wall at a 1/2 inch thick. Sound rating, again, SDC are better for a 6-inch concrete thickness. Thicker concrete is a better rating. So again, if you're doing something like a duplex, the party wall can use a 6-inch ICF with a 1/2 inch drywall on each side. You'll get the better than a 1-hour fire rating that you need, and you'll get that STC of 50 that you're looking for. Certain applications, something like an elevator shaft, you need a slightly higher STC rating. I think it's 54. So then we'll typically go to an 8-inch ICF, and we achieve that rating. Vapor permeance. Okay, the maximum allowable vapor permeance as per National Building Code is 60 nanograms per Pascal second meter squared. So in other words, each square meter of wall at a 1 Pascal pressure difference can't allow more than 60 billionths of a gram of water through per second. When we test Nudura's 2 5/8 inch Type 2 EPS, we come in at approximately 36 nanograms per Pascal second meter squared. And that's just a straight divisive relationship between the thickness of a given material and its vapor permeance. So to be a type 2 EPS, your maximum vapor permeance is 90 nanograms per inch thickness. So a type 2, basically once you're hitting about 1.5 inches, you're meeting the NBC requirements for vapor barrier. Adding additional vapor barriers can trap moisture, causing potential problems. This is really important, and I've had this discussion with a number of building officials over the years. They still want to see a poly added to the wall. Not only is it not necessary, I would argue that it's potentially dangerous because, by having the EPS foam acting as your vapor barrier and then adding an additional layer of poly inside that, any moisture trapped between the ICF and the poly really can't escape. So then you get moisture buildup and certain issues that can arise from that. So I would strongly advise against the additional use of a vapor barrier on the inside of an ICF wall. Downproofing is only required where the interior finish elevation is lower than the backfill. So in other words, going back to that crawl space I showed you earlier with the attached garage, now because the fill on the outside and the inside of that garage is going to be at the same elevation, you do not need to backfill it. If you're doing a frost wall under a commercial building, typically not required. A walkout basement's a good example. Your frost wall under the walkout side, normally you don't need to add any downproofing to that. Just below the point of what's normally, the interior slab typically. Must be EPS compatible. Again, same thing we talked about the adhesives earlier on, making sure they're not solvent based, making sure it's not going to react negatively with the ICF forms. And a protective layer may be required. So if you're doing a peel and stick membrane and you've got a really aggressive backfill with a bunch of sharp rocks that could puncture it during the backfill process, you might want to add something, whether that be some plywood or an additional layer of plastic or something like that, just to make sure you don't puncture. The membranes are pretty robust, so they do take a lot of abuse before there's failure. But if it's concerned, it's something that you might want to consider, or bringing in sand or something as a safer backfill. So there's basically 3 types available for ICF: peel and stick, drainage board, or a spray on or roll on. So there's a peel and stick. It's comes in a roll, self-adhesive. Some need a primer, some don't. And it's just applied directly to a clean ICF, making sure that the temperature and site conditions are conducive to it. Spray on, or sometimes it's a roll on, again, making sure it's an EPS safe version. And there's a number of manufacturers that offer ICF safe versions of these types of products now. And your dimple board, which is, again, mechanically fastened, typically from grade level down. Plumbing, you typically don't put lines in an exterior wall, but they're just cored in after the concrete's placed. If you're doing something like, again, if you're going back to a duplex and the kitchen wall is on one of the interior walls, this might come to play. But just making sure that they're buried sufficiently below the foam that you're not going to hit a line with a drywall screw. Same thing goes with electrical. Because our ties are about 5/8 of an inch below the surface, you want to go up to 1 5/8 inch drywall screw rather than 1 1/4 inch. So with that in mind, keep your channels at least 1.5 inches below the surface. If a drywall screw lands right on top of one of your channels, you're not going to penetrate deep enough to actually hit that wire. Boxes must be securely fastened. So you can glue them, you can tap on them, you can screw them to the web. There's even specialty ICF boxes now that are plastic, and they have these kind of claws on each side of the box that just stab into the foam. They're really nice. They're a little more expensive, but they're really user friendly. So that's kind of what it looks like. Again, the channels are just created with, you can use a skill saw, chainsaw, router, hot knife, whatever have you, just to make sure you get them to a safe depth. And how not to build. Again, this comes down to proper training. If you're new to ICF, align yourself with whether it be a distributor or a manufacturer that can offer at least some level of training. It's not a terribly difficult thing to stack ICF, but when you're dealing with concrete, if you don't have it right the first day, you're really stuck with that on day 2. Voids, honeycombing, it's tough because you can't actually see the foam. You can't see the concrete through the foam, rather. If you have an experienced ICF installer or even an experienced concrete person, they're going to be able to, for one, lay out the rebar in such a way that it doesn't restrict the concrete flow. Also making sure you get the proper concrete mix. So proper slump, proper aggregate size, And again, proper consolidation with an internal vibrator, and an experienced crew will be able to avoid these types of issues. An easy way to check if there's certain areas, whether it be a couple of windows that are close together, or maybe some service penetrations that were placed close together, you can always just take a little screwdriver and stab it through the foam. If it goes more than 2 5/8 of an inch in, well, you likely have a void there and you want to cut it open. If it's small, you're going to patch it with some non-shrink grout and move along. You can tap the forms and you'll hear a hollow sound inside if you do ever run into voids or honeycombing. So there are, non-invasive ways of sort of checking some potential problem areas. But again, assuming the concrete mix is proper, and you don't lay the rebar out in such a way to impede the flow of the concrete, this is not a huge issue in my mind. This is obviously a catastrophic failure. I have no idea what happened with this one. It looks like a post and beam style ICF, but obviously something was done horribly wrong. So I've never seen anything even approaching remotely close to that in almost 2 decades, fortunately. Certification. So there's no universal certification. You can't be a certified ICF installer, but you can be a certified, whether it be Nudura or whichever manufacturer you're dealing with, they will provide product certification. Some are better than others. So, and I can't speak to each of our competitors, how they handle it. But I know Nudura, they've offered an online course right now, which is free, and it's broken up into 6 modules. You can do it at your leisure. It's really good. It's geared very much toward the builder. It's detailed. COVID sort of forced us to an online option for a couple of years, so it was based off our classroom courses that we've been running for, basically 2 decades. That gets you your first step towards certification. Your second step is after you do 2 ICF installs that a distributor goes, we inspect them. If they're done properly, then we sign you off to become a trained installer. So it's pretty in depth, but it shows that you have both a theoretical and a practical knowledge toward the product. Other suppliers, I've talked to people, I bought this particular product and I'm certified. Oh, how many jobs did you do? And he said, well, none. When he sent out the block for my first foundation, he delivered the card with it. So again, the certification is only worth as much as the distributor, the manufacturer, puts into it, unfortunately. Certain municipalities do want to see a certification number prior to the permit being approved. It's a kind of a catch-22 because you're telling someone that, well, we want you to be certified to build, but you need to build to be certified. So what we'll do is use another certified installer. Typically, us as a distributor, I would put my own number on it and just do a pre-pour inspection to ensure everything is done properly. So currently ICF is about 2% of total commercial and residential construction in North America. It may be a little bit higher than that now with the increasing cost of lumber in the last few years. We saw pretty good growth of market share just because of logistical challenges that other products were experiencing, and as well as just simplicity of having all of that done with one product. Geographically popular. So there are pockets where you're going to see, Kitchener-Waterloo area in Ontario, there's a ton of mid-rise and high-rise buildings done with ICF. You go to another area and it might be completely unheard of. So things like schools, hospitals, hotels are done with ICF. Again, a lot of that is a result of the energy efficiency of the product, but also those secondary benefits. So the sound ratings, fire rating, mold resistance, and speed of construction is huge. When you're able to, again, accomplish 6 steps with one product, you're able to get some pretty good production on your sites. And growth is expected. Again, logistical challenges. When you're doing an ICF, concrete seemed to be in no short supply, at least in our area. Steel, rebar, never seemed to be a shortage of that. We were able to procure product over the last few years, whereas lumber and insulation and poly and different products were having a bit more of a difficult time. So sourcing one product instead of 6 is attractive for builders and developers. And again, just as the pool of experienced builders is growing and their expertise with the product, people are getting more comfortable using ICF because they don't feel like they're being the guinea pig, and they know they can trust their chosen builder to do a nice job with it. Simple construction is simple training. And this is one thing I kind of want to finish off with. Now, when you're looking at First Nations construction, and we've done a lot of projects on First Nation from you know, family to multifamily housing to light commercial work. I know a lot of these communities want to employ local labor, and that is important. I think it's a great initiative. The nice thing about ICF, if you have one or two people on site that know the product, it is a pretty simple thing to learn. So you can train someone to come and be a laborer, someone that's in charge of rebar, someone that's in charge of block. And as long as you have one or two people overseeing the whole thing and looking at some of those fine details or some of that minutia, it can really go well. So, and after a few jobs, in my experience, these guys that are relatively new to the product get a few jobs under their belt, and all of a sudden they're kind of the right-hand man to the foreman. So that's really key when you're looking at some of these and you know what, it's good for remote communities too. If you're not able to get a crew to travel, being able to bring one or two guys in that are maybe experienced and doing the rest with local labor is a really attractive part of these types of buildings. So I want to thank you for your time. I know I took up more time than I should have. If there are any questions, feel free to ask now.
A
But
few
there's
minutes.
my phone number and email are there. So
Yeah, we got a few minutes here. We're okay to go a few
okay.
minutes over. Anybody have
Okay.
any questions? While we're filling those, I just want to show, it's like here. Where are we here? I gotta do a share screen. Where we go? Share. Okay, I'm gonna share. So I think I just shared my screen.
We can see you, John.
So I'll just give you, I put ICF at my house. So this was the back of my house. I had a porch with a waterfalls coming off the back, and there's a little bit of screened in, and we decide, okay, well, we want to go to a 3-season, and then we decided to actually advice with Keith and through of a First Nation contractor says, no, you need to build. So I put in an ICF, and the reason I did it, it was more money to install, but in terms of energy saving, then I didn't have to put vapor barrier in. I didn't have to all the additional cost. Money per, like my value was so much positive, especially in an older home. And so that's my ICF that's being installed. I had to get this trucking from Cornwall because of electrical wires and pump it in. There was a bit of a logistical, and of course, you know, the change work orders, as we talk about. This was a change work order bringing this pumper truck in from Cornwall. That was extra 2,000. This is the basement. What I found interesting, and even today, so Tyler, I had plastic on the edges here. So when I was hanging pictures, I had to find those plastics, and there was so it was hard to detect. But you just have to know what your spacing is, and then once you find it, you can hang stuff up. They're actually reinforcing a wall. That's what those guys are doing. And actually, this is actually my office underneath here, and this is just the beam across, and they're putting the flooring on. And again, just quickly, this is no longer the waterfalls, my back of my house, and that's literally my basement. I'm looking out this window right here in my office. But I have heated floors and ICF, and when it's like minus 30 here, I'm able to keep around 16, 17 degrees, and the temperature is fantastic. And maybe I'll raise it in February. Oh, I may go to 18, but for a basement, it's toasty, and upstairs. So that was just
Yeah.
my ICF experience.
Yeah, no, and that's a good point you raised, John. The product there that you had with the exposed strips, that product's no longer around. I'm familiar with it. But now as far as finding, so I live in a full ICF house. I did my basement and my main floor with ICF. And you're
Yeah.
right, with the foundation, and that's a pretty common feedback, is that not only do you have a foundation that's warm and cheap to heat, but maybe more so anecdotally, I find that people say it's more of a dry space. So I grew up in a house that was born built in the early 80s, And it was always very cool and very damp. You had to put a dehumidifier down there. It wasn't really comfortable. When I moved into my own house, it kind of confused us that our main floor was maybe set to 18 or 19 degrees. Our basement was sitting at about 25 degrees. So we actually had to plug off a bunch of our registers because it was too hot down there. And again, it just seems to me that talking with past customers, there's the EPS foam, I think, handles humidity maybe a little bit better than a fiberglass batt insulation. So not only are you getting a warm basement, but it's very dry. So it becomes a much more comfortable, usable space.
Yeah. And we actually, then we spray foamed the upstairs. So we have, it's very cool in the summer, and it's very pleasant back there. So that was my experience, and I do it again. Yeah, it's more money, but and I had problems with getting a contractor, and I know even now today, I know other contractors, it's really hard to find ICF people, like trained. Like, and they're paying really good money, the installs as well. So it's hard, it's not as hard as the foam. So I know, again, a foundation guy, like doing the old, the old forms, that's a hard grind. This actually isn't as hard on the body as well, doing ICFs.
Yeah, that's true.
You can live longer before arthritis sits in. So,
No, and that's a good point. And we do a lot of work early where, it used to be that, even when I was working construction, 20 years ago, a lot of the small town ready mixes, they would rent out the plywood forms. Well, they've since kind of rotted in the back and they've never really been replaced. So a lot of rural customers like the fact that, for one, you can't get a subcontractor that owns their own plywood forms to travel there and do the work for you,
yeah.
and you have nowhere locally to rent the forms. So this becomes a really good option where. And the other thing is you're not limited to wall height. It's not like you need to own 8 foot and 9 foot and 10 foot forms or try and join them together like you're doing with the cast in place option. Rather, you just buy 8 feet or 9 feet or 10 feet worth of ICF and leave it there.
Yeah. So I have a question from Elvis. Is ICF manufacturing companies affiliated with any home warranty programs at the structural level?
So our product itself carries a warranty, just saying that, the product specs, the sound rating, the fire rating, the insulating value won't drop for, I believe it's 30 years. The new home warranty program, I mean, that's more builder specific. So
Right.
that would depend on the builder carrying the appropriate accreditation.
Yeah. Okay. Any other questions, comments? I guess
I don't
not.
see any at this time, John. I think this has really been a good informative presentation, Tyler. I thought I knew a fair amount about ICF, but your presentation was really hit the mark and certainly presented it really, I guess, me with a different view of Nudura as a really good product.
Excellent. No, and I just want to thank everyone for taking the time here. I got a bit long-winded here. And a huge thank you to John and Claude for organizing this for us. And again, please share my my contact information. So if anybody has questions regarding the product or a specific project maybe you have coming up, whether it be budget or scheduling or technical information, feel free to reach out to me directly. And if I can't help you, I'll get you in touch with someone locally that would be able to. And also, if there is something in particular that you'd like more information on, feel free to let me know. If there's enough of an appetite for it, I'd happily do another presentation tailored to a more specific project, more specific topic, because I know this was pretty vague and kind of went through at a quick pace, but I'd be happy to chat further about something if there's interest.
I'm thinking crawl spaces. That's a huge issue.
Yeah. Okay.
Yeah. So we can talk further on that. So.
Sure thing. I will also, one last thing, through Concrete Sask, we're hosting an ICFMA, or in partnership with the ICFMA, we are doing an ICF seminar coming up potentially at the start of December. So if anybody's local to the Saskatchewan area, and you want to learn more, it's going to be we've done one prior to COVID a few years ago, and it was a really well done presentation. So it's something you can look up Concrete's Ask if you're interested in attending. And I know some of the other provinces are going to be doing similar programs.
Actually, send that to David Cooper and Vinny at PAGC, because they will be able to network that in Saskatchewan for you. So
For sure, I will do that.
yeah, okay. All right, thank you, everyone. And yeah, what is your contact? Elvis, we'll get that to you after. So I'll send that to you. And we'll share the slides along with the PowerPoint. Thank you, everyone. Have a great day. And until then, we're on Monday for our next webinar. So thanks, everyone.